Hello everyone, I'm Masanori from the University of Tokyo. This presentation is for BESC 2022, and then my presentation title is Parameter Tuning Method for Multi-Agent Simulation using the Reinforcement Learning. I'll explain about multi-agent simulation. Multi-agent simulation is usually called MAS, and then the simulation using the many agent and then by powering up agent behavior, simulate social phenomena or other kind of phenomena. Multi-agent simulation can see the emergent phenomena of complex system caused by agent-complex interaction, and it is very useful tool for the understanding social phenomena. And another artificial market simulation is a multi-agent simulation for financial market, and artificial market simulation is a very good tool for understanding the financial phenomena because the agent interaction is very necessary to replicate the stylized fact. Stylized fact is a well-known phenomenon in financial market all over the world, and then many models are proposed for this simulation. Usual multi-agent simulation, there is three procedures to building the multi-agent simulation. First one is a model. Modeling is important because the human have to make the simulation model, and second procedure is parameter tuning. Parameter tuning is also important too because it is hard to replicate the actual phenomena in society. So we have to take care of the parameter to replicate the actual phenomena. And then at first we have to evaluate the analysis the simulation to check the actual phenomena is replicated or not. So for this parameter tuning for multi-agent simulation is very difficult. It is because multi-agent simulation has many parameters and the response of parameter change is not always linear. And many multi-agent simulation is used for and used mainly for complex system analysis, and then the complex system analysis system shows usually chaotic phenomena. So tuning the parameter is very difficult. This difficulty, and we propose a new tuning method using the deep reinforcement learning. So usually for tuning the parameter, Bayesian optimization-based tuning method such as opportuner is usually used. However, we assume that social simulation and Bayesian optimization seems incompatible because um, uh, the variance between the trial for simulation is very different, and chaotic phenomena or phase transition is frequent occurs. So the Bayesian optimization seems incompatible those simulation, I think. And then moreover, recent development of the deep reinforcement learning is very promising, and deep reinforcement learning can handle high dimensional parameter space or some kind of chaotic things. So in this study, we try to use reinforcement learning for multi-agent parameter tuning. Model outline. So in a usual parameter tuning scheme, parameter tuner make a parameter set and then run the simulation and analyze and get the objective values, and then feedback the objective value to the parameter tuner to get the better parameter set. However, DDPG for mass PT, this is our proposed method. In this, our proposed method, actor-critic-based reinforcement learning is employed, and actor generates the parameter set, and then simulation and analyzer is also run and get the objective values, and then critic predict the objective value based on the parameter set, and then the critic is run to minimize the difference between the objective value and the prediction. And then the actor is also trained to maximize the objective value through the critic backpropagation of the critic. The actor critic based reinforcement learning model, we employ the DDPG. It is because the DDPG can support the continuous action space, and then the parameter of the maturation simulation model is also a continuous space. So we decided to employ the DDPG. Here is information about the architecture used in the DDPG, and then the general architecture widely used in reinforcement learning, such as replay buffer or soft target, is also used in this model. And the as an exploration noise, Uran-based process is employed in this model. So, in our model, actor-critic-based reinforcement learning is important because we assume that the critic works as a surrogation of simulator and analyzers. So, thanks to this surrogation, actor can learn the parameter set to maximize the objective value through the backpropagation of through the critic. Next, I'll explain about the detailed implementation of our proposed method. So, DDPG format PT consists from the four factors. First one is a customized DDPG for our task because the input-output relation is different from the usual parameter, usual reinforcement learning. And then also we propose additional three components called action converter, redundant for neural network actor, and seed fixer. According to our results, all of them are required to realize our idea. Customization of DDPG. So as I mentioned earlier, the 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 task is very different from the usual reinforcement learning task because there are no state exists because parameter tuning is not Markov process, and only it is one-shot trial. So for each iteration, the actor generates the parameter set without any input as a first equation. Then, using the parameter set, critic predicts the objective value, and then the relation between the parameter set and objective value um, through the MSE minimization as a second equation. And at last, using the trained critic, actor runs the actor updated to maximize the objective value. Next, the first additional component called action converter. Action converter converts action spaces. It is mainly used for implement the non-negative restriction. So the action probability discussion of SAC is also similar but different from this, and this is only aimed to mapping between the space to space. In our experiment, we employed the sort plus function for some reasons. Here is the second component, addition component, reliance for neural network actors. So as I mentioned earlier, the actor accepts no input, and generates the parameter set. So minimum requirement is a parameter enabled, a gradient enabled parameters. However, in our proposition, reliant neural network is employed to generate the parameter set. It means that dummy one vector is accepted, and then the through neural network parameter set is generated. In our assumption, this neural network is works as a kind of collective intelligence, and then this is also according to the rotary hypothesis. The fixer. So usually in March agent simulation, the random parameter is employed because the replicating the probabilistic decision-making process, the randomness is necessary. So However, this causes the difference between the trials, even if the parameter is same. So in social simulation, usually the effect of random seeds is more than the effect of parameters. So in our proposition is fix this seed. Here is those two figures represent this idea, and the left figure shows that when seeds are different, and the right one is when the seed is the same, and then if the seed is different, even if the parameter is the same, the result of each trial is different. However, when the seed is fixed, uh, when the parameter set is slightly different, the result is slightly different. It make easy to get the gradient between the two parameter difference. To evaluate our proposed model, we made a simulation model and ran the experiment. So as the target of our evaluation, we employ the artificial market simulation, and then the simulation model is started through the agent proposed in the previous work. In this simulation, agent calculates their bidding price based on the three factors: fundamentals and charges and noise. More detailed algorithm is shown in the paper, so please read this that. And then we tuned only two parameters. It is because this is a very earlier work of this proposed method. So here is the experiment and results. Objective function is of this experiment is MSE of the skewness and courtesy of price log written of our financial market simulation. And target is skewness is 0 0.0 and courtesy is 6.0. And we choose only two parameters, and then the other comparative modules, we employ the opportune Bayesian estimation, and then the method missing one or two components of our proposed three additional components. According to our results, our proposed module shows the best performance. Here is your discussion on the future works, and according to our results, our proposed method works well, and three additional components, action component for neural network, actor, and seed fixer were necessary, and critics works well as a surrogation model of simulation as we assumed at first. So on the other however, the task we used in this study is very simple, only tuning two parameters. So it is because the Bayesian estimation has a limitation of supporting high-dimensional tuning. On the other hand, gradient-based method such as DDPG can support high-dimensional tuning. So, according to some previous work, DDPG can solve high-dimensional tasks. Therefore, it seems a good fit for tuning high-dimensional parameter tuning task. So, as a future work, we should test reinforcement learning module with a high-dimensional tuning task, and moreover, reinforcement learning model with high exploration capability should also be tested. Thank you for listening.